Question number 71. Highest dipole moment is possessed by. We have different options given here, and we should always know that whenever we talk about this dipole moment, this is dependent on the polarity in the molecule, and that polarity is dependent on the difference in the electronegativity of the constituent elements present in the compound. So if we talk about the first molecule, that is F2O. In this case, the constituent elements are fluorine and oxygen, and the electronegativity difference is not that much. And in that case, the mu value, if you find out, it is 0.3 dBi. Now, after this, we have the next molecule, that is H2O, the well-known water molecule. And here are two elements. One is hydrogen, other is oxygen. The electronegativity difference is a lot. And we know that mu is equal to Q into D. So, this Q is more in this case. And this mu value is equal to 1.87 dBi. Now, after this, the third molecule, ammonia molecule is here. And in case of ammonia molecule, this mu value is 1.47 dBi. Why so? Because the electronegativity difference is very much, but not more than this H2O. Now, after this, it is a turn for NF3. For NF3 molecule, this mu value is less as compared to NH3, and that value is 0.23 dBi. So all the mu values, all the dipole moment values I have mentioned here, and in this case you can clearly identify this with the help of knowing the difference in electronegativity. And if we look at the molecule water, that has the maximum, the highest dipole moment among the given species. So this is the correct answer that I'm just going to choose here. Further, let's take next question. Question number 72. Wrong statement among the following is. The first statement, pH5 and NCl5 do not exist. Yes, this is the correct statement. Now, you might be thinking why it is correct. If we talk about pH5, phosphorus atom is there, hydrogen atom is there. Though phosphorus can extend its octet, but the difference in the atomic size is very much. That is why these two elements are not compatible. They are not combining to form pH5 molecule. And that is why this molecule does not exist. While if we talk about NCl5, in case of NCl5, nitrogen cannot expand its octet because unavailability of d orbital. That is why this molecule also does not exist. Further, we have the second statement. P-pi, D-pi bonds are present in SO3. So if we talk about this SO3 molecule, the structure is like this. And in this case, both P-pi, D-pi bonds are possible. So if we talk about this, suppose I'm talking about this, in this case, there are P-pi, P-pi bonding in one of the case. While in these two cases, there is P-pi, D-pi bonding. And here is P-pi, D-pi bonding also. Because sulfur atom, due to the presence of d orbital, can form this P-pi, D-pi bond. Further, this statement is the correct statement. After this, we have the third statement. CCl bond is stronger in C2H5Cl and C2H3Cl. It means if you compare these two, the CCl bond is stronger in case of C2H5Cl. Let's check the structure of these two. So if we talk about the C2H5Cl, this is the structure of this compound, and the next one is C2H3. It means double bond is there. This is the next molecule, and in this structure you can clearly see, just have a look on the C2H3Cl. In this case, this carbon and chlorine bond has partial double bond character, because we know that this carbon is sp2 hybridized. On that basis, this has partial double bond character, and that results in more strengthening of the bond. It means the bond that's present here is this bond. Talking about this bond is more strong as compared to this bond. And if it is so, it means this statement is the wrong statement. So this is the wrong statement. Let's check next also. Lattice energy of lithium fluoride is higher than cesium iodide. This is also a correct statement, because in case of lithium fluoride, both the ions, if we talk about Li positive ion or F negative ion, both are the smaller in size, and that is why more strong bond is formed there, and that results in high lattice energy. While in case of CSI, iodide ion and cesium ion, both are the ions which are larger in size, that is why this has less lattice energy, and that's why this statement is also correct. On that basis, we can choose here the correct option, that is option 3, which represent the statement that is incorrect. So answer is option 3. Let's take next question. Now question number 73. Which among the following is not a planar molecule? We have different options given here. So if we talk about the first option, that is BCl3, it is a triangular planar structure. It means this is a planar molecule. If we talk about C2H4, that is sp2 hybridized, and this is also the planar molecule. Then we have SF4. If we talk about this SF4, SF4 has the structure that you might be knowing. It is seesaw-like structure due to the presence of this lone pair, and this is not a planar molecule. But if we talk about H2O, this is a bent molecule, and this is a planar molecule also. So on that basis, which option is correct? This option 3 is the correct option for this particular question. After this, let's take next question. Question number 74. Molecule which does not possess odd electron is. We know that octet rule states that if an atom has 8 electrons in the valence shell, that would be considered as stable. There were several exceptions to the octet rule also. And if we talk about odd electron species, those are also considered as the exception to octet rule. NO, NO2 and this ClO2. These are considered as the odd electron molecule in which one electron is present as the odd electron. While if we talk about the Cl2O, I'm just drawing its structure. The Cl2O has this type of structure in which the paired electrons are present in these orbitals. And that is why this is not the odd electron molecule. And that's why I'll choose this option 4 as the correct answer for this particular question. And after this, question number 75, correct order of solubility of salts in water is. We have different salts. Let's check what are these salts. Potassium fluoride, rubidium fluoride, sodium fluoride and lithium fluoride. In all the given options, these salts are compared and we have to choose the correct order of solubility. Basically, we can solve this on the basis of the fact that the solubility of the fluorides of group 1 elements decreases down the group. And on that basis, we consider the reason here hydration enthalpy and the lattice enthalpy. There are the two factors which are the deciding factors. One is the lattice enthalpy or simply the lattice energy that is required to break the lattice of that particular crystal. And if we talk about the other thing, that is hydration enthalpy or the hydration energy. When you dissolve a particular solute in a solvent, hydration energy is released and that is utilized by that molecule to break the lattice. It means it is utilized as the lattice energy. So for the solubility of a particular salt in a particular solvent, always this hydration enthalpy or hydration energy should be more as compared to lattice energy. And if it is possible in that particular case, definitely that would be soluble in that solvent. So if we compare the given salts, if we talk about potassium fluoride, that has a larger size as compared to sodium or lithium, but it has less size as compared to rubidium. So what we need to find out in this case, we have to compare the size of the ions present there. In all of these cases, the fluoride ion is present there as the anion. That is same for all of these cases. It means we have to compare the metal ion here. Metal ion, rubidium, we have rubidium ion. We have potassium ion, we have sodium ion and lithium ion. If we compare the sizes of these species, rubidium has the largest size while this lithium has the smallest size. In case of this rubidium ion, least amount of lattice energy is required. So hydration enthalpy can overcome that process to give rise the breaking of lattice and that results in the dissolution. So this Rb positive that is forming rubidium fluoride ion has the nature to be dissolved in water maximum, then there would be Kf, further NaF would be there, and then there would be lithium fluoride, the least one. So where this option is given, it is given in option 3. So I'll choose it as the correct option, and it is the answer for this particular question also. Now, let's take the next question.